So the wall up there obviously comes all the way through to where Josh is working, so roughly where that gate is, we then gonna mimic that, where the wall obviously runs down to a gradient to the point over there. As we come round to here, roughly where the gate is, the wall on this curved wall round past the hot tub obviously comes down to this point. So we've now got to work out the gradient or the fall from that point there, come down, coming down, coming down, coming down, coming down, coming down to there. So to do that, we need, this is the point at the top of the plinths where Josh is up on the top there, where we just looked, up there. So he's up there, so that represents that point there. This was my laser. When I did my laser, I had 120mm down to the top, just underside of the half rounds. And then I put the staff onto here, which is this point. But we are going to be 1200 higher there, because obviously all the soil comes down. So that's the 1200 that we're coming up. So that is the soil height. So I've got 120 down of my laser line, and I've got 1200 up to there, and then that is, like I said, where the soil is going to be. So I need this distance, and then I can do my calculation. So I'll have my distance. I can work my fall out as soon as I've got this, and between them two I can then work the gradient out. So to work out what the gradient is going to be, we just need the distance divided by the fall, and that will give us the gradient. And if we want to work out falls or distances, all we need are these three figures. So for example, here we go, this is what we're going to be doing here. The distance divided by the fall will give us a 1 in 5 gradient, and 5 is the number that we take. So for example, if we wanted to find the distance, we use those two figures, but we just multiply the fall by the gradient, and that will give us a distance if we didn't know that. Or if we didn't know what the fall was, say you're doing drainage, you know the length of drain run you've got, you know the gradient, 1 in 40 or whatever it is going to be, so you divide the distance of the gradient and you'll get the fall, so you know how far you're going to go into a trench. So they're the three figures you need, and by knowing which ones you're going to divide and which ones you're going to multiply, there's only one you're going to multiply. You've got to get these obviously the right way around as well, but you can work out your gradients, your distances and your falls by using those. So, like I said, just going back to R1, this was the figure that I had on the staff. We minus that because that is the height of the brickwork. The soil, I think I mentioned the soil's there, but the soil is going to be down this high. So this is going to be obviously above, because this is going to be like all the fancy dental work that comes from up top there. So this is our finished brickwork height, and that is the finished brickwork height there. So they're just taking that off the laser line and taking that away gives us a measurement of 2 meters and 30. So we have a fall of 2 meters and 30. I'm now going to double check the distance, because when I roughly did it I had like 21 meters, but I'm now going to do a proper one, and obviously with those two measurements I can then work the gradient out. So I've worked out the distance, and that came to 20 meters 800. So we know what the fall is, that's 2 meters there, and that's 20 meters. So I'll do all my calculation in meters, not in millimeters. So 20.8 divided by 2.03 gave me 10.2 10.24, so I've got a 1 in 10.24 gradient. So what I want to now do is put those into here. So I've got my distance, and I want 2 meters because I've marked everything in 2 meter increments. So I just want to get what the fall is in 2 meters. So 2 meters, and I've got to divide that by 10.24, and that will give me the fall over 2 meters. And just to do a double check, this is a fall over 2 meters. So if I divided that by 2 to give me a fall over a meter, that was 0.0975, I think, something like that. If you then multiply that by the total distance, we should have that. And when I just did that, it was that. So 10 mil. So that's good enough.